talking about measuring the velocity versus time of a falling object. And Mr. T, what's the relationship between velocity and time?
Well, let's see. Change in velocity over a change in time is equal to acceleration.
Okay, so really we're going to be measuring the acceleration of a falling object. We've got two setups. We've got the dot timer, which we are used to. Let's see, how many times a second does that make a dot, Mr. T?
60 times per second, I believe.
Oh yeah, that's right. Okay, I remember now. We're going to drop an object, attach the tape, bring in some dots, and we actually be able to measure it the same way we did the cart rolling down the ramp.
Right. So we have 60 dots per second. As it falls, it's going to leave spaces between those dots. Just like we did for the car coming down the ramp, we measure every 6 spaces will be 1/10 of a second.
Yeah.
So we have our displacement, and then we have our time.
And if you want to make it three dots would be, what would 3 dots be? 0.05 seconds?
Mm-hmm.
Yeah, so if you want to, you can space it out that way too. 6 dots for 0.1 seconds, 3 dots for 0.05 seconds. All right, that's good. That's one way we're going to do it. We also have a high-tech computer system here. We'll drop, let's see, how does this work?
All right, so this we call our picket fence. All right, just a piece of plastic. We have some tape on it. This right here, we have a photo gate. So every time this gate is blocked, the computer registers that it's blocked.
Mr. T, gate?
A photo gate.
What the heck is a photo gate?
Yeah.
Excuse my unprofessional language.
So the photo gate measures when something is blocked. We can essentially measure distance and time or velocity.
Mr. T, what's getting blocked? I don't see anything.
That's right. Well, there's a laser.
Oh, it's a laser.
There's a laser. Yeah.
Oh, that's cool.
So we have a laser in here that shoots across right through this little gap right here. And when it's blocked, the computer senses it.
Cool.
All right. And
Wow, this is high tech.
Yeah.
So what happens?
All right. So what we do basically, and we'll talk about this in class, but we have our Logger Pro software that we'll pull up on our computers. Can you help me there?
Sure, yeah, I can do whatever you want.
So here's what I'd like you to do. If you can hold that picket fence up above,
Okay.
all right, nice and steady.
Okay.
And we're going to have you, in a moment, we're going to have you drop it
Okay.
through that photo gate.
I'm going to drop it through the laser beam.
Drop it through
The one that I can't see.
That's right.
Okay. Like the infrared or something.
That's right. As these pieces of tape go through, it's going to block and unblock the beam, and the computer's going to register.
And the computer knows when it's what? So the computer knows the distance between one block and the next block?
Right, so we've pre-measured the distance from the start of one black tape to the next start of the other black tape.
Okay.
We enter that into the program so it knows how far things are going. Hit collect, and then we drop it. So here we go. So I'm going to hit collect, and if you would, on my command, drop it down.
On your command, sir.
Be sure to catch it so we don't drop this on the floor and crack it open. All right?
I'm a novice dropper and catcher, so.
All right, go for it.
All right, here we go.
Drop it through.
Ooh, look at that, I got it.
That was excellent. Nice
I was a little
catch.
worried there.
All right. Let me see if I can.
Here.
Well, yeah.
Let's see what you got.
All right.
Steady cam it over.
So if we look, this is why it's great. Before we were hand drawing all these graphs.
Okay.
This Logger Pro program graphs it all for us. Here's displacement versus time.
Oh, I like that. It kind of looks parabolic there, a little
That's right.
curvy.
Yep. And here is velocity versus time.
That's strange. Wasn't it falling down?
It was falling down.
Why
yeah.
is the velocity positive?
Well, it's a good question.
Is it just we're supposed to know the physics and that it's really negative, but it's hard to plot negative, so we just plot positive?
Absolutely. Yeah.
Oh, that makes sense.
And we'll talk about the details with all that. And here's the acceleration versus time. So
Okay.
in a split second, we have 3 graphs that you used to do by hand.
Oh, that's
and
nice.
now are right here. So we'll do some analyzing based on this, and we'll find out that this program is very helpful.
Cool.
All right.
All right, so I guess we'll do it old school way first, dot timer, and then we'll check out the results from the new one, the cool laser beam one. All right,
That's
awesome.
it.
We'll be back.
All right.
just going to tape the ball to the dot timer tape. The ball can be our falling object, and then we'll be able to see how far it's gone based on the tape. Ooh, I think we're going to need more tape.
Set it up, put it up there.
Yeah, let's do it. And during class, I guess, if you're doing this lab, you'll be the person handling the dot timer, huh? And everybody will just come over to you and you'll feed it in and turn it on and then turn it off.
Ready?
Yes, sir.
Here we go.
Oh! Go. Nice deep dot.
Alright, and here we go.
Yes.
That was a good one. That
Right.
was a good one.
All right. Nice. Look at those dots. Man, they are much more spaced out than the... There they are. They're much more spaced out than the original cart on a ramp that we did.
Mm-hmm.
There they are. There they are. So every 3 dots is 0.5?
0.05.
0.05, right. Every 3 dots, 0.05. Every 6 dots is 0.1.
Right.
So we've got 2 options that we can do. Mr. T, we could graph average velocity versus time of each interval like we did with the car down the ramp.
Right.
Or actually, we could do the lab number 5 way, which is square the time and plot distance versus the square of the time. Ooh, either one's going to give us a straight line. One of them will give us the one of us will give us the acceleration. The other one will give us the acceleration times a number. And as long as we know that number, we can figure out what the acceleration actually is.
Exactly. Right.
Okay, so we've got 2 options here. You can use the lab 5
T-squared method.
t-squared method or the lab 3 ramp down a cart average velocity versus time method. Very cool. I'm really, really interested of seeing the data for the picket fence. We should probably check that out. Do you need to go get something?
Yeah, let's go. I got to go take care of a couple things over here.
Okay.
Come back and we'll get to that.
All right, sounds good.
All right, so, all right. Oh, I forgot something. I got to go grab something. I'll be right back.
Okay. Okay.
Gotta see this.
Okay. What do we got? Cool. All right, so you got what you got. Let's see.
All right, let's take a look. So we got some nice data here.
That's really awesome.
Distance versus time, velocity versus time, and acceleration versus time. So we'll talk about how these look, how they're supposed to look, if these make sense, and we're going to find out using the program how to find slope of specifically this quantity here.
Oh man, I can't wait to show my kids that. That's going to be so cool.
It's going to be really nice. And
Yeah.
I think they're going to love it because this is really quick and very efficient and a lot easier to use overall.
Yeah, that's awesome.
It's going to help writing those formal lab reports a lot easier.
Nice. So you're going to show the students this, and I'll show the students this, and then the students will do it themselves with the dot timer. Yes, sir? All right. So This is us signing off.
Till next time.
Yeah, we have to talk to Miss Lawrence. Maybe she can be part of one of our write-ups.
Yeah.
I don't know.
Well, I think, all right.